Hello guys, welcome back to my channel. I hope you're doing well. So recently I've been doing the past papers for IGCSE Physics for May June 2024 series. So last time I did paper 41. So if you want to watch that one, it would be linked down in the description below. So today I'll be doing the IGCSE Physics May June 2024 paper 42. So let's start with the first question. A load is suspended from a thread. The vertical force on the thread due to the load is 0.75 newtons. Calculate the mass on the load. So, mass, so we know that weight is equals to mass times gravity. And since gravity is 9.81, so we have the weight which is 0.75. So 0.75 equals mass times 9.8. So we just divide both sides by 9.8. That would give us the mass to be 0.77 grams, or I mean kilograms. That's going to be the mass. Part B. Figure 1.1 shows the load suspended from the thread. Alright. A wire is attached to the load at point X and pulled horizontally to the right. Okay, so we're pulling this to the right. The tension in the horizontal wire is 1.2 newtons. By drawing a scale diagram or by calculations, okay, determine the magnitude of there's a force at X due to the load and due to the tension in the wire, and the direction of the resultant force, the resultant relative to the vertical direction. All right. So this is about 4 marks. So this is very common in recent papers. So let me just explain what's happening first. So as you can see, there is a wire and the load is producing a force downwards. So we have like a downward force from the load. And that downward force is, as we can see from the previous question, 0.75 newtons. So that means the downward force is 0.75 newtons. And they told us that at point X, the load is pulled horizontally to the right. So that means we have a force to the right. Let me just redraw that. And that force is 1.2 newtons. And we're supposed to find the resultant force. So that is going to be facing bottom right. That's the resultant force. So they told us we can draw a scale diagram or we can do calculation. So I'll do a calculation because that could be faster. So what we use is Pythagoras theorem. So we know that 0.75 squared plus 1.2 squared, that would give us, let's call this one r, that would give us r squared. So if we root both sides, r would be root of 0.75 squared plus 1.2 squared. So when we do that, 0.75 squared plus 1.2 squared, and then we root it, we get r equals 1.4 newtons. So resultant force is 1.4. Now then, they asked us to find direction of resultant relative to the vertical. So what they mean by that is we just have to find the angle to the angle of the resultant to the vertical axis. So if we take this angle is between the horizontal line and the resultant force. So this is not what we're talking about. This is the angle between the vertical axis and the resultant force. So we just have to find this angle. For now, we can just call it theta. So there are multiple ways to find it. So we use the trigonometric ratios, or basically Soka Toa. So to find theta, we have the opposite one and we have the adjacent one. So we can use tan. So we know that tan theta equals opposite over adjacent. So it's 1.2 over 0.75. So that would give us 1.6. That would give us 1.6. So tan theta is 1.6. So if we do tan inverse on both sides, that would give us 57.99 degrees, or we can just write it as 58 degrees. So that's how we could easily get those 4 marks. So it's 58 degrees to the vertical and 1.4 Newton. Forces may produce changes in the size and the shape of an object. All right. State 2 other changes that a force may produce. Okay. So they've already told us they can produce change in size and object, which is also known as deformation. So the other thing, they can produce a change in speed. They can produce a change in direction. So this can be the 2. We can also say they can produce change in velocity. So we can write those. Question number 2, define acceleration. So acceleration is the change in velocity per unit time. That's acceleration. In formula, it can be the change in velocity over time, or the final velocity minus initial velocity over time. That's the formula for acceleration. And any of these answers would be fine. A train has a total mass of 520,000 kilograms. The train accelerates at 1.1 meters per second squared. Calculate the time taken for the train to increase its speed from 50 meters per second to 28 meters per second. All right. So they've given us mass and acceleration. Okay, so now we can use this formula for acceleration. Final velocity minus initial over time. That's acceleration. So we have the acceleration, which is 1.1. Final velocity is 28 minus initial velocity, which is 15, over time. So now we can just rearrange this. So that would give us 1.1 t equals 28 minus 15. Let me just rewrite that. 28 minus 15. So 28 minus 15, and then we divide that by 1.1. So divide both sides by 1.1. That would give us 13. Wait. That would give us 11.8. Or we can just write it as 12 to 2 significant figures. Either way, it's okay. Part 2. Calculate the force required to produce an acceleration of 1.1 meters per second for this train. Okay, so for this one, we use the formula for force. So we know that force equals mass times acceleration. So our force would be, our mass is 520,000, I believe. Yeah, 520,000. Acceleration is 1.1. So our force would be 572,000 newtons. That's going to be our answer. Part 3. The train uses electric motors. Explain why the force on the train due to the motors is greater than the value calculated in part 2. So we calculated the force due to the mass and acceleration, but we should also consider the friction. We can say friction because in reality there's friction and there's air resistance, so the train has to exert more force to overcome those resistive forces like friction and air resistance. Part 3. A student drops a heavy ball from a vertical height of 1.8 meter above the ground. The ball then falls to the ground. It does not bounce after hitting the ground. Okay. Describe the transfer of energy of the ball between the stores from when the ball begins to fall to when it reaches the ground. And they specifically told us it does not bounce. So that means there's no elastic energy, elastic strain energy. We do not consider that. So initially, when the ball was at a height, let's say it dropped, at this height it has gravitational potential energy. So initially, it had gravitational potential energy. And after that, once the ball is dropping down, it increases its kinetic energy. Then we can say kinetic energy increases. So after that, so once the ball has reached the bottom, it does not bounce, so it just stays on the ground. So that means it will have internal energy. So we can say once the ball reaches the ground, it will have internal energy. That's what we need to try for 3 marks. So make sure to mention the gravitational potential energy, the kinetic energy increasing, and lastly, the internal energy. Those are the 3 places where we're going to get the 3 marks from. Part B, calculate the maximum speed of the ball. Ignore air resistance. Show you're working. All right. So what do we mean by the maximum speed? So as we know, when the ball is falling down, at the top it has the highest GPE, and in between it has the highest kinetic energy as the ball is moving down before hitting the floor. So maximum speed is when all the gravitational potential energy transferred to become kinetic energy. So at the maximum speed, all of the gravitational energy has become kinetic energy. So at max speed, GPE equals kinetic energy. That's what we need to know. So formula for gravitational potential energy, that's mgh, and formula for kinetic energy, that's half mv squared. So the m's could cancel each other. As we know, g is 9.8, and I believe we have the height, yes. So it's 9.8, the height is 1.8, equals half of v squared. So 9.8 times 1.8, that would give 17.64 equals v squared over 2. So we can multiply both sides by 2. That would give us v squared equals 35.28. We just have to root 35.28. Finally, we get 5.9. That's our maximum speed. So we can write 5.9 meters per second. That is our final answer. Question number 4. State 2 ways that evaporation differs from boiling. Alright. So one of the difference is evaporation happens at any temperature. Evaporation happens at any temperature. And the other one is evaporation is only on the surface. So evaporation is only on the surface of the liquid. So what we mean by that is if we have like a water over here, if the water is evaporating, only the top part of the water is evaporating, and after that, once the top part has evaporated, the next layer would evaporate. But if we're boiling this water, the whole water would boil. So the boiling happens throughout the whole part of the water, while evaporation is only on the surface or on the top. Part B. Figure 4.1 shows a container used to store a mixture of liquid and gaseous oxygen. The temperature of liquid oxygen is minus 160 degrees Celsius. Determine the temperature of the liquid oxygen in kelvins. Okay, so to convert to Kelvin, we just have to add 273 from minus 160. So that would give us 113. So we have 113 kelvins. Part 2. The container is made of steel and there is a vacuum between the inner and outer walls. The outer wall of the container is at room temperature. State two methods of thermal energy transfer that a vacuum prevents. Okay, so as we know, we have three main methods of thermal energy transfer: conduction, convection, and radiation. So this is mostly through solids, this is through gas and liquid, and this is through vacuum. So that's a quick recap. So state two methods that a vacuum prevents. So conduction and convection cannot pass through a vacuum, or that cannot happen when there's a vacuum. So our answer is going to be conduction and convection. That's our answer. Part 3. Describe in terms of particles how a gas exerts a pressure on the walls of its container. Okay. So as we know, gas particles, they are all very far apart from each other and they're always moving around. So what we can say is the particles collide with the walls of the container. So when they collide, they exert a force on the walls. So they exert force on the walls of the container. And since we know that pressure equals force over area, there will be pressure on the walls. That's the explanation. The particles collide, and when they're colliding, they'll exert certain amount of forces in certain areas of the wall. So, and since pressure is force over area, so pressure is exerted on the walls. Question number 5. Okay. Figure 5.1 shows a ray of yellow light incident on a glass prism APC. Okay. Explain why the ray does not change direction when it enters the prism at face AB. Okay. So whenever this happens, if we draw, okay, so the light, there's a normal line. Whenever we have refraction, there's always a normal line which is perpendicular, and we have the incident ray, and this incident ray is refracted, or the light rays bend. So whenever there's no bending, that means that this yellow light is perpendicular to line AB, meaning it's on the normal line. So if we draw the normal line, it's on the yellow light, and we have a 90-degree over here. So we can say the light ray travels along the normal. That's our answer. The critical angle for glass is 42 degrees. Calculate the refractive index of the glass. Show you're working. Okay. So refractive index, which is n, that's equals to 1 over sine c. Whenever we have a critical angle, it's always 1 over sine c. That's the formula. So it's n equals 1 over sine 42 degrees, because critical angle is 42. So 1 over sine 42, that would give us 1.49. We can just write 1.5. On figure 5.1, continue the path of the light through the prism after it leaves the prism. So let's look at the diagram. Let me just remove all this. So they're telling us to draw the path of the yellow light. So first what we have to do is we have to draw a perpendicular line, which is a normal line, 90 degrees. So this is 90 degrees. So now we have to measure this angle. So I can't show you exactly, but when measuring this angle, it would come up to around approximately 60 degrees. So this is approximately 60 degrees. So since it's 60 degrees, it would be reflected. So the rules are, if the incident is greater than the critical angle, so in this case critical angle is 42 degrees, it would be reflected. Total internal reflection would happen. And if the incident is equals to the critical angle, the refracted line will be along the boundary, along this line. But since it's greater than 42, it would be reflected, and we would also have 60 degrees angle over here. So now we can see that the ray is incident on line AC. Let me just... The ray incident is incident on line AC. Since it's incident, we also have to draw another normal line for line AC. So it's pretty close. So this is perpendicular. So this line is perpendicular to line AC. So that means it would just be a straight line going downwards. No refraction will happen because it's directly on the normal line due to this 90-degree angle formed. Part C. Internet data can be transferred using infrared waves in optical fibers. State two advantages of using optical fibers to transmit data. So one of them is we're using infrared data, so it's going to travel fast. So we can say fast transmission. And you can also carry large amount of data. large amounts of data. Plus, it's also secure. So any of these 2 points would be fine. Question 6. A sound wave travels through air. Figure 6.1 shows a pressure time graph for the air at one place, okay? Label 1.c to indicate compression and R to indicate refraction, alright? So let's try and understand the graph first. So our baseline, this is atmospheric pressure, which is about 101 kilopascals. So compression is where there's the highest amount of pressure because there's a large density of molecules. So this could be compression. And refraction is the opposite, so the lowest amount of pressure. So this could be R. Explain why this graph cannot be used to find the wavelength of a sound wave. So we can not use it because the graph doesn't show displacement, it shows atmospheric pressure. So it's pressure time graph, not a distance time graph. So we can write graph shows pressure and not distance. Or we can say displacement of wave. To find the wavelength, we look at the displacement time graph of a wave, not a pressure time graph. Part 3. The sound becomes louder and of lower pitch. Louder and lower pitch state what happens to the amplitude of the sound. So amplitude directly relates to loudness, and the pitch relates to frequency. So if it's louder, that means amplitude increases, and if it's a lower pitch, frequency decreases. That's what you need to know. Part B. A sound of frequency 13 kilohertz is transmitted through water. The speed of sound in water is 1500. Calculate the wavelength of sound in water. Alright. So we know that speed is frequency times wavelength. So the speed is 1500. Frequency is 13 kilohertz, which is 13,000 hertz. And we have the wavelength. So divide both sides by 13,000. So 1500 divided by 13,000, that should give us 0.12. So wavelength equals 0.12 meters. Don't forget the units. State the approximate speed of sound in air. So that's, we can say, 330 meters per second. It's always a constant value. Question number 7. Figure 7.1 shows 3 bars of steel A, B, C. Alright. A student is given the 3 pieces of steel. 2 of the pieces are magnetized and 1 piece is unmagnetized. Okay. Describe and explain how the student determine which piece is unmagnetized using only the 3 pieces of metal. Alright. Or the 3 pieces of steel. That's a very interesting question. So to do this test, what we can do is we can say, firstly, we need to bring close 2 of the steel and see if they attract. And after that, we flip it and try it with different ends of the magnet. with changing the ends, or we can flip the steels, because a magnet has, let's say, a north pole and a south pole, and if B is the other magnetized one, it also have north pole and south pole. So if the north pole comes to the north pole, they would repel. So if they repel, both are magnets. So what can I say? What we can say is try with changing the ends, and we should repeat this with the other steel too. So we can say repeat with the other piece of steel. And after that, how would we know which one is a magnet, which one is not a magnet? So we can say the two steels that repel are magnets. Because if it's not a magnet, it won't have a north pole and a south pole, so it would always be attracted to the other magnet. But if it's a magnet, south pole and south pole would not attract each other, they would repel. That's how we know if it's a magnet or not. Part B. Figure 7.2 shows a circuit diagram of a step-down transformer. So a step-down transformer, for those who don't know, is a transformer that reduces the voltage. The mains voltage supplied to the transformer is 240 volts. The output power of the transformer is 45 watts. The transformer is 100% efficient. Calculate the input current. The input current to the transformer. Alright. So if it's 100% efficient, that means the output power of the transformer is equals to the input power. So we know that power equals voltage times current. So the current of the input times voltage of the input, we can say current of input and voltage of input equals current of output times voltage of output. Because we know for a transformer, which is 100% efficient, power is the same, it doesn't reduce. So that means the output power of the transformer is 45 watts. So this side is 45. And we have the input voltage, which is 240 volts. So 240 volts times the current, that would give us 45. So divide both sides by 240. So that would give us 45 over 240. That is 0.19 amps, of course. So that's the current. So to draw a transformer, first we have an iron core, a soft iron core. So that would just be a rectangle. Let me just redraw that. And then we have a rectangle inside too. Excuse my bad drawing. So this is the iron core, and we have coil on both sides. Since this is a step down transformer, we would have the input, the primary coil. So the primary coil should be more than the secondary coil if it's a step down transformer. So over here we have like 1, 2, 3, 4, 5, 6 coils. So that means maybe we'd have like 3 coils on this one because it's a step down. So we have input voltage and output voltage. And then this is the secondary coil, since they told us to label it. So secondary coil. And this is the primary coil. and this is the iron core. And we should also label a suitable material for each. So the coils are usually copper. So we can just write copper. So this is a full complete diagram for a step-down transformer. Question 8. Figure 8.1 shows the circuit designed to switch on a night light when the surroundings are dark. Alright. So on figure 8.1, draw a circuit symbol for a voltmeter used to measure the potential difference across the light-dependent resistor LDR. Interesting. So if you want to measure the voltage of the LDR, it should be parallel to this is the LDR, so it should be parallel to the LDR. So to draw that, we would just make like a conjunction, and we draw a voltmeter. And then we have the two junctions. Part 2. The surroundings change from light to dark. State the effect of this change on the resistance of the LDR. So in an LDR, when the surrounding becomes darker, the resistance increases. So when the resistance increases, we know that voltage equals IR. So when the resistance increases, voltage also increases. So we can say the potential difference increases. And part 2. State and explain. Okay, I think I made a mistake in part 1. So the effect of change in the resistance of LDR. So we're focusing on the LDR. So resistance increases. That's what you have to know. In LDR, if it gets darker, resistance increases, and the vice versa. Part 2. State and explain the effect of this change on the potential difference across the LED. So if the surrounding become darker, what happens to the LED? So we've established that the LDR has increased resistance. Okay. So the potential difference across the LED also increases. We can write PD across the LED increases. This is because, so let's say this is a fixed resistor. So let's say it's 5 ohms, and this one changes. It increases and decreases according to the light. So if this increases, the proportion of the LDR of the total resistance increases. So initially, if this was let's say 2 ohms, so the total ohms is 7. So if this increases then to like 8 ohms, the total would be 13 ohms. So the proportion of LDR increases, or the how much the LDR is contributing to the total resistance, it increases. So because of that, as I've mentioned earlier, potential difference or voltage is directly related to resistance. So if this resistance increases, voltage also increases. So we can say greater proportion of the total potential difference is across the LDR. So I hope I've made this clear. So, but I'll explain again. So the LDR has initially, let's say 2 ohms. So this is producing 2 ohms. This is producing 5 ohms. So this part has greater potential difference. So it has greater PD. because it's contributing more. It has more resistance. But after that, this increases to 8 ohms. So if this increases to 8 ohms and this is still 5 ohms, now this will have the greater potential difference. So this voltage value would be higher. And since the LED is across the LDR, so when the resistance increases, the PD also increases. So the LED will become brighter or it lights up. That's the main explanation. Part B. Figure 8.2 shows another circuit. Lamps A and B are identical filament lamps. The current supplied by the power supply is 0.5 amps. Calculate the resistance of lamp A. Okay. Now we know the lamps are identical, so the total resistance is going to be the same. The total resistance, once we find the total resistance, we can find the resistance of the lamp. So the current is 0.5 amps. So now we just have to find the total resistance. So we know that V equals IR. Rearranging this, R equals V over I. So the resistance, the total resistance, that is 240 over, how much is that? 0.5. Now we get 240 over 0.5, that gives us 480. So total resistance is 480. Now these two lamps are connected in parallel. So what that means is we have the formula 1 over RT equals 1 over R1 plus 1 over R2. And what this means is there's also another formula when resistors are in parallel. It's RT equals R1 times R2 over R1 plus R2. So we can use this formula. This would be much easier. So the total resistance is 480. But R1 and R2 are the same, so we can just say R. So R times R, that gives us R squared equals 2R, because R plus R, that gives us 2R. Now we cross multiply, we have 980, 480 times 2, that gives us 960. 960R equals R squared. So if we divide both sides by R, we can get rid of this squared. So the one of the resistance is 960. So that's going to be our answer. So both A and B have resistance of 960. Question number 9. Radioactive isotopes that emit ionizing radiation are used in hospitals. State and explain 2 safety precautions necessary for the use of these isotopes in medical procedures. So the first safety procedure could be reduce exposure time. Now, what would this prevent is you would absorb less of the radiation. So we can say less radiation absorbed. And the next one is we can say keep keep as far away as possible. So this will also do the same thing. There would be lower amount of radiation reaching the people. And there are also other examples, such as using a lead lined box so that no radiation would be able to escape when stored, but two would be enough. Part 2. Give two reasons why alpha emitters are not used as radioactive tracers inside the body. So, what's usually used for checking inside the body or looking inside the body? It's usually gamma rays and X-rays. So the reason alpha radiation is not used is one of them. One of the reason is it has low penetration. So because of that, it can't reach the detector outside the body. So it won't be able to penetrate through the body and reach the detector. So that's why it's not used. The next one, it has high ionization. It's actually the particle with the highest ionization from the three of them, the alpha, the beta, and the gamma. This one is the one with the highest ionization. So that would be very dangerous to use inside the body. Part B. Sodium 24 has an isotope of sodium that has a proton number of 11, nucleon number of 24. Sodium 24 decays by emission. Sodium 24 decays by emission of beta particle. So since it's a beta particle, it's gonna emit it's gonna emit a beta particle. So the proton number would increase by 1, and the mass number would stay the same to form an isotope of magnesium. So use nuclide notation to write down the nuclide equation for this decay. So sodium 24, so it's Na, and proton number of 11 and 24 is the mass number, yeah. So when this decays, it would form magnesium isotope. So, and also a beta particle. So this beta particle has 0 mass number and a -1 of proton number. So the sum of the particles on one side should be equal to the sum on the other side. So since the lower number is 11, the sum over here should also be 11. So that means this would be 12. 12 minus 1, that would give us 11. And over here, since nothing has changed because of the beta particle, magnesium would be 24 too. So that's going to be the nuclide notation. Number 10. The solar system includes the sun and planets. State two other types of natural objects that orbit the sun. So one of them is asteroids and comets. State the shape of orbits of the planet. So it's elliptical. So what we can say is elliptical. It's not a circle, it's elliptical. So the shape is something like this, like an oval, and the sun is not exactly at the center. Figure 10.1 shows an orbit of an object around the sun. At point A, the object is closest to the sun. At point B, the object is furthest away from the sun. State and explain the energy transfer as the object travels from point A to point B. So what happens is at point A, it's closest to the sun. So there's high gravitational energy attracting it towards the sun. So that means it would be moving at higher speeds at A. So that means kinetic energy is highest at A, and gravitational, or we can say potential energy, is highest at B. So from A to B, kinetic energy decreases. And potential energy increases. And for the explanation, all the kinetic energy is transferred to potential energy. So energy is conserved. That's going to be our answer. Part D. Jupiter is 7.8 times 10 to the power of 11 meters from the sun. Speed of light in a vacuum is 3 times 10 to the power of 8. Calculate the time taken for light to reach the sun. For light to reach from the sun to reach Jupiter. Okay, so we know speed is distance over time. So speed is 3 times 10 to the power of 8, and distance is 7.8 times 10 to the power of 11, and we don't know the time. So rearranging this formula, the time is 0.8 times 10 to the power of 11 divided by 3 times 10 to the power of 8. So that would give us 2.6 times 10 to the power of 3 seconds, or 2,600 seconds. Name the galaxy that contains the sun. So that's the Milky Way galaxy. Light observed from a distant galaxy is redshifted. Okay, state the theory of the universe that this observation supports. So it supports the Big Bang theory. So how it supports the Big Bang theory is that farther objects are redshifted. So across, okay, a long period of after a long period of time, some galaxies are being redshifted, and they're appearing to be red. So that means those galaxies are moving further and further away from the center. So that's how it supports the Big Bang theory. Cosmic microwave background radiation is observed at all points in space. State when this radiation was produced. So this was produced right after the Big Bang. So right after the Big Bang, or right after the universe was formed by the Big Bang. Explain why this radiation is now in the microwave region of the electromagnetic spectrum. So this is the same thing we were talking about earlier. So this has been redshifted. So the radiation has been redshifted. So redshifted basically means the wavelength increases. So firstly, it was a gamma ray. So after a gamma ray, the wavelength increased, became an X-ray. The wavelength increased again until it became microwave. So that's what redshifted means. So has been redshifted, and wavelength has increased. That was the last question. So if you've enjoyed, make sure to like and subscribe. And if you have any questions, make sure to drop them down below in the comments. And thank you for watching.